All right, so this is number 3 in Web 23. I wrote the function here. Now, right away, when you see an x to the x, what's the word that you think you're going to probably end up doing? Logarithmic differentiation. We're going to have to use the EVLN trick when we take the derivative because we have an x to the x. And chances are good there'll be one like that on the final. Logarithmic is just, again, like the harder differentiation stuff. So logarithmic differentiation. So if we take the derivative, we know we're going to do that. Now, first off, well, why are they asking us this? So on the domain of all positive numbers, okay, we're only looking at from 0 to infinity. And that's because when you have an x to the x less than 0, it gets really weird because we have a fractional. You get a fractional exponent and you have the square root of a negative number. It gets really weird. So we're only going to go from 0 to infinity, so that's nice. So what is this function as we get to 0? And you guys remember that? What's 0 to the 0? Yeah, 1. Which one wins? The exponent wins. Now, is 0 to the 5 times 0 1? Or is it 5? So, we know we've already shown we've already shown that the limit as x approaches 0 of x to the x is equal to 1. But now we want to go x to the 5x. Is it still 1? Or is it maybe 5? Now, it would be 5 if there was a 5 in front of it. Right? You just multiply the answer by 5. But there isn't. It's a 5 up here. But maybe when we take the derivative, the 5 comes down. You don't think so? Okay. And besides, we're not taking the derivative. We're doing a limit. So, all right, well, we got to prove it though, right? We can't just assume that. All right, so how do we do that? So we want the limit as x approaches 0. So how do we do that limit? So let's write it the normal way. Limit as x approaches 0 of x to the 5x. Now remember, we did this before with x to the x. So this is not logarithmic differentiation, it's logarithmic limits. So you go, what? It's not a fraction. We can't use L'Hopital's rule. Like, oh, what do? So you do what you do. You say, okay, that's the same thing. I'm not going to write limit anymore. That's the same thing as e to the ln of x to the 5x. Right? That's the logarithmic trick. E to the ln cancel, so it's the same thing. Now, we can rewrite that as e to the 5x ln of x. Right? Because log takes exponents in front. That's why we do it. Okay. And I'm not writing limit here because I'm lazy. So we know this is a limit. Now, remember, what's the next step? What do we do now? Right. Now we just say, let's forget the e, but we can't remember. We got to remember to come back to it. Okay, I know I've forgotten that. I've had grade tests. You'll forget to it. We can't forget the e, but now let's do the limit as this approaches 0. And then we got to put our answer up here. So now we want the limit as x approaches 0, just the exponent of 5x ln of x. Okay, well, how do we do that? It's not a fraction. We can't use L'Hopital's rule. So what do? And we make it a fraction. We force it into a fraction. So we have two options. We can put the ln of x in the bottom or the 5x in the bottom. Actually, let's just take the 5 out. Okay? 5 just means we multiply our answer by 5. So let's put the 5 over here, and let's just put x ln of x. So x ln of x. We got to put one of them in the bottom. And sometimes it's not clear which one. So let's put the x in the bottom. So this would be 5 limit as x approaches 0 of ln of x divided by an x on the top is an x to the negative 1 in the bottom. Right? X to the negative 1 is 1 over x, which means in the top. And that's a really bad negative 1. Okay. If I'd put the ln of x in the bottom, I would have had to say ln of x to negative 1. That's kind of weird, right? So we don't want to do that. So it's easier to say x to negative 1. Okay, now we take the derivative of the top and the bottom. And I really shouldn't say equals, because it's not equal. It's not the same thing, but it works. So that goes to, okay, can't forget the 5. Derivative of ln of x, super easy, that's 1 over x, divided by, okay, now we're L'Hopital's rule, right? So we can take the derivative of the top, derivative of the bottom, derivative of that is negative 1 x to the negative 2. Let's simplify that. Negative in the bottom means it's in the top. And it's negative. So this is the same thing. Let's say negative 5. Put the negative up here and take it out. Negative 5. X to the negative 2 in the bottom is x squared in the top. So we have an x squared in the top divided by x. We have a 1 over x, but the x squared goes to the top. Well, that's just negative 5x. Now we can plug in x equals 0. So it's 0. Because ln of 0 is infinity and 1 over x is, because, right, why am I plugging 0 in the beginning? Because ln of 0 is infinity, and we have 0 times infinity, which means we don't know the answer. Yeah, good question. I forgot to say that. We don't know the answer because we have 0. Which one wins? Turns out the 0 wins. Right, we're not done yet. Now we go back to the e. So the exponent is 0. So the limit as e to the 0 is 1. So finally, our limit is x goes to 0 of x to the 5x is equal to 1. Turns out the 5 doesn't matter because, yes, we get a 5 out of it, but it's 0. So 5 times 0 is still 0. So just like x to the x to the 5x is also goes to 1. So the answer is 1. Okay, anyway, so that is a limit using logarithmic. It's not really differentiation, it's logarithmic limits, kind of. Yeah. Okay. But again, same tool. E to the ln can be used for both taking derivatives and used for taking limits. So that's a good thing to remember. All right, so that's it. So we know it goes to 1, so that's interesting. So when we graph this, remember the whole point is to graph this. So now we know what our left endpoint is. When we graph this, we know that x equals 0, it goes to 1. So there's 1. So we know it goes here. Now it's like what to do over here. We don't care about negative. As they say, we only consider positive, but now what's to do?
Wait, sorry, I don't understand that I'm wait, why is it when it's going to go to 1?
Because we just showed that. As x goes to 0, this
fine.
goes to 1. Yeah, that's what. So the whole point is, as we go towards 0, what does this do? Because it's 0 to the 0. Turns out it goes to 1. Actually, I shouldn't put a closed circle there, huh? I should put an open circle at 1. You really can't get there. But 0 to the 0 equals 1. Not equals, but it. Yeah, saying it equals 1. I'm not sure you can do that. But in the limit that we approach 0, x to the x goes to 1. I'm not sure you can say 0 to the 0 power is 1. I guess is it a closed circle or an open circle? I'm pretty sure it's an open circle. Yeah. No, yeah, Chase, yeah.
So you could say, so you agree that no matter what number you put up there would be x?
I think we just showed that it doesn't matter if it's a 5 or not. It could be a quadrillion. Well, yeah, that number doesn't matter. Yeah, I think we could have called that a K. We could have tried just put a letter in, and it turns out it doesn't matter. 5 doesn't matter. So yeah. Okay, cool. That was fun. Now let's see what else we want to know. Are there intercepts? True or false? The function is null. Okay, now we got to look at the intercepts, asymptotes. What happens as we go to infinity? Okay, so let's look at this. Are there any So in other words, we know it starts here. Are there any x-intercepts? Does it go down and go through 0? Okay, can this thing ever be negative? A positive number to the power cannot be negative. It can be a fraction, but it can't be negative. We're only considering positive x's. So it doesn't matter what's up here. If this is negative, it's a fraction. It's 1 over it. But cannot be negative. Therefore, there can be no x-intercepts. It can't go down below the axis here and cross the x-axis. It starts at 1, and it can maybe hit it, but it can't go below it. Actually, could it hit it? And how could it possibly hit it? Because a positive number to a positive number is always going to be a positive number. The only way it could possibly hit it is when x equals 0, and we know it doesn't.
Yeah.
So I think we can basically say no x-intercept anything if that's true. There's no way we can get that this is 0, and there's no way it can be negative. Okay, how about the y-axis is a vertical asymptote? Wait, is this an asymptote? It doesn't go to infinity there, right? It goes to 1. Asymptotes, it goes to infinity. So I think we have to say, I guess what's the definition of an asymptote? Gets closer and closer but never gets there? An asymptote is, the limit is infinity. It goes to infinity. So we have to say no. True or false is a vertical asymptote. That'd be false. I'll check to make sure. Actually, but yeah, asymptotes go to infinity. So that's going to be the answer here. I think that's the answer to infinity. Yep, see, they do the same thing. They say false. Okay, we're good so far. X equals 1. Okay, we're on the right track here. Right for us. Okay, how about as x goes to infinity? What is the horizontal asymptote? Remember, there's only 1 here. We can't go to negative infinity because x has to be positive. So as x goes to positive infinity, what does this equal? Can we assume that infinity to infinity is infinity? You have to show that. I think that we can say, we plug in infinity to the infinity power. I think that's safe to say that that's a pretty big infinity, right? So I think we could probably say it's positive infinity, obviously. What is the formula for the derivative? Okay, now we got to practice the derivative. And remember, logarithmic derivatives. E to the ln. We take the derivative. So let's just quickly go over that. So we have x to the 5x. So we go e to the ln of x to the 5x, which is e to the 5x ln of x. Now we take the derivative. The derivative of e to the anything is e to the anything, which is the original thing. So it's always the original thing times the derivative of this, right? The derivative of e to the anything is e to the anything times the derivative of the anything. So what's the derivative of this? So it's always going to be a plus. You've got to put parentheses because it has just something plus something. It's a product rule. The derivative of the first times the second. The derivative of 5x is 5. So 5 ln of x plus the first 5x times the derivative of ln of x, which is 1 over x. Now that's just extremely easy to cancel out the x's, okay? And we should take out the 5. There's a 5 in both places. We put that in front. So it's 5x to the 5x times ln of x plus 1. That's got 5. Plus 1. So those cancel. So take out the 5. So the simplest way to write it is 5x to 5x times ln of x plus 1. We get a lot of these tricky. Not everyone got them right in the quizzes. So be careful of that. Okay, how many critical numbers are there? Are there critical numbers or where the derivative is 0 or infinity or undefined? Or sharp points. It's hard to get sharp points. So, but where the derivative is undefined or is zero. I don't think there's any undefined here. So where is this zero? Well, we know that this can't be zero. So when is ln of x equal to 1? Equal to negative 1? Well, does the log of x, can we get the log of x to be negative? And sure we can, because let's just remember, so we want, for this to be 0, everybody agree ln of x has to be negative 1, right? Negative 1 plus 1 is 0. Okay, so how do we solve this if it's confusing to you? You raise both sides to the e. E to the ln of x cancels it, that's x. So x is e to the negative 1, which is just 1 over e. So this is 0 at 1 over e. In other words, ln of 1 over e is equal to negative 1. That's because e to what power? Remember, ln returns the power. E to what power gives you negative 1? Sorry. Yeah, it's negative. So negative 1 is the power. So the power is negative 1. E to the negative 1 is 1 over e. Backwards, but. All right, so there you go. We have one critical point, which is one critical number, which is 1 over e. How many critical numbers are there? Just one. Wait. It's also undefined. Is it? What happens at x equals 0? Oh, we already did x equals 0. It goes to 1.
Yeah, this one doesn't get that.
It doesn't get there.
That's what happened.
Right. Right. So the slope, but 0 is not technically in the domain of the problem because it doesn't get there. We had to approach it. So ln of 0 is undefined, but I don't think we can get there. So I think there's only one number. That's a tricky point there. So I would say 1. Okay, let's see what they say. See if they agree with us. Infinity, we got that right. Okay, I didn't take out the 5, x to 5x is 5 ln of x, and 3 to 1. Yeah, there's one critical number. Okay, we know it's 1 over e. Yep, so far so good. Okay, we don't want to keep this the next one. So far so good. There is only one, because 0 doesn't really count. 1 over e, say, let's move on now. Smallest critical number is only 1. The largest interval in the domain which the function is increasing. Where is the derivative positive? Okay, the derivative, y prime, is that 5x to the 5x times ln of x plus 1. The critical point is 1 over e. So we only have to look at, so here's 1 over e, that's like 1/3 or something. So here's 1, here's 1 over e. So all we gotta do is look at what is the derivative on this side and what's the derivative on that side. Well, one there. There's only one critical number. That's real easy. We only have two things to look at. What is it on one side, what's on the other side? There's nothing interesting else going on. There's no other asymptotes. So that's easy. So what's the derivative over here? And what's the derivative on the big side? So let's plug in a really big number. If we plug in a big number for x, the derivative is clearly positive, right? So f prime, so we have 1 over e on our number line. So f prime is definitely greater than 0 over here. How about on this side of 1 over e? Let's put a tiny number. ln of 0 is negative infinity. ln of a tiny number is like infinity. Negative infinity. plug in ln of 0.001 in your calculator. It's going to be a big negative number, a lot bigger than 1. So this is going to be negative when x is like 0.01. And what's 0.01 to the 0.01? Well, it's clearly a positive number. This only can be positive. So definitely the slope is negative over here. F prime is less than 0. On this side it's less, and this side it's greater. That means, what's it look like? It looks like this, right? Negative, positive. So there must be a minimum there at 1 over e. If it's negative on one side of it and positive on the other side of it, gotta be a minimum. We know it's 0 there. We know the slope is 0 because that's what we figured out. It's a critical number. The slope is 0 at 1 over e. And now we know it's a minimum. So it must go down like it must look like my picture. I just got lucky, so it must look like my picture there. And it starts off here and goes down and then goes up. It doesn't go to 0. It goes down and goes up, and right there is 1 over e. And doesn't do anything else interesting. There's no other critical numbers. You know it doesn't do any more wiggles. If it had another wiggle, there'd be another maximum. Or another inflection point. Ooh, we have another inflection point. Ah, darn. We gotta take the second derivative of this? I would think there would be with only one minimum. How could there be another inflection point? Can we assume that? Can we say, oh, it can't be? I think we can assume that. Wait, if it's, oh wait, yes, we know that forever the derivative is greater than 0 over here, and forever it's less than 0. Therefore, it's concave up. And for an inflection point, yeah, it makes sense there can't be. I'm trying to decide if we actually have to prove that or not. Or can we just say obviously?
Well, I mean, if it goes
I don't want to take the second derivative.
as x goes to infinity, the values are just in the power of infinity. So
Yeah, as x goes to infinity, it goes to infinity. It doesn't do any weird wiggle. I think. Now we had to take it if we had to. Maybe they're gonna make us do it. If we had to, out in front here, we already did that derivative. The derivative of this is this whole thing. So it'd be the product. It'll be the derivative of this is the whole thing times this plus this times the derivative of that. And the derivative of that's pretty easy. Just 1 over x. So the second derivative would not be that hard to do. We already did the hard part. But why do it if we don't have to? Okay, let's see if they're going to make us do that. Okay, oh my gosh, they do. Okay, we know there's a local minimum occurring at 1 over e. Oh, they want us to find the y value. Okay, so at 1 over e, comma, they want the y value. So you got to plug 1 over e into this equation. So 1 over e to the 5 over e power. There's no way that that's going to be like a nice pretty thing, right? It's going to be a decimal, some decimal. I don't think we can say that. Well, let's see. Got e to the negative 1, the 5e to the negative 1. Power to power, you multiply powers. So that's e to the negative 5e to the negative 1. That's still not pretty. Okay, there can't be a pretty way to write that. I don't think that should be like 1 over e or something. But again, I mean, we could leave it like that. But I wouldn't know how to graph that. I don't know how to put that in the graph. We want to be able to put a dot in the graph. So we want to get a decimal for that. So you guys got just calculate a problem. Because they want the point. We want to plot that point. In other words, what is this point right here? How low does it get? And I plotted, what is that point right here? I know it's 1 over e, which is like a third. 1 over 2.7. Anyway, so you can figure that out. But they do want us to take the derivative. So okay, remember it's not that bad. Let's do it. So here is our function right here. Here's the first derivative. Okay? Now the second derivative is the derivative of this, which is the whole thing. So the second derivative is, I'll do it over here to have room, is that whole thing, 5x to the 5x times ln of x plus 1. Derivative of the first times the second. So times, oh, look, I can just put a squared. Squared, right? Derivative of the first, which is the whole thing, that was the first problem, times the second, which is ln of x plus 1, so it's just ln of x plus 1 squared, plus the first, 5x to the 5x, times the derivative of this. Derivative of 1 is 0, derivative of ln of x is 1 over x. So that's just 1 over x. So that wasn't really that bad. I just copied the first answer, put a squared. So that is our second derivative. Everybody see how that works? Derivative of the first, which was the original problem, so that's the whole answer. Oh, wait, I forgot, but it's got the, yeah, with the 5. The 5. So derivative of x to 5x. Yeah. Wait, I did it wrong. I think it's 25. The derivative of x to the 5x is this. The derivative of 5x to the 5x is 5 times that. It should be a 25 there. Because the derivative of x to the 5x is this. So the derivative of this, of 5x to 5x, is 5 times that. Okay, true or false? The function is concave up at 1/10. It's always concave up. As far as I know, it's always concave up, right? From here it goes down, it goes up. There's no other inflection points. There's no inflection points. Always concave up. So yes, that's true. Because anywhere it's concave up. Craziness. Are we done yet? True. The function is concave up at x equals 1. It's always concave up, yes. Uh-oh, they're scaring me saying that. We better check. 1 over e infinity. The formula is, okay, how about these answers? True. Okay, good. True. It is true. Are we going to be able to finish? We have 3 minutes. Hey, we can finish this. The value of x goes infinity of the derivative. As x goes infinity, the derivative is infinity, right? Yeah, it's infinity because this is ln of infinity is infinity, and x to the 5x is infinity. So as the slope gets steeper and steeper and steeper, which makes sense. It goes to infinity, right? Which is super infinity.
Oh.
No, we do know that. Infinity times 0 we don't know. Infinity times infinity is super infinity. So yeah, so that's clear. So the slope, in other words, gets steeper and steeper and steeper. So it gets steeper and steeper and steeper. Okay, now we're good. Now we just match up the graph with what theirs looks like. So which one do we think it is? It sure looks like it's plot B, huh? So it's definitely B. It goes down and then up. Okay, so that was pretty easy. So let's see here. Yep, it's B, of course, we knew that. All right, so that was that one. Pretty cool. Pretty boring graph, but kind of interesting. Okay, so do number 4 in its entirety for tomorrow. Try to plug all the way through it. Some of you guys kind of fizzled out on yesterday's. So do number 4 for tomorrow. Then we'll do number 5 tomorrow in class because it's late start tomorrow. We might not be able to finish. But then we'll get out the practice quiz and see where we are at this. Yeah. Okay, cool.